By the end of this video, you'll have learned how to run queries on legal documents such as Apple's App Store Terms of Service, shown in this video right now. With a few lines of code and the click of a button, you'll be able to answer valuable questions about your company's legal documents. Questions like, does this document grant a company the right to use my data? Or, does this document have a force majeure liability limitation clause? And even how unbalanced or unfair are the terms of this contract? All of this and more is possible with the world's first universal legal classifier, Kanon 1. Before we begin harnessing the power of this legal superweapon, it is worth briefly discussing what a universal classifier is, and why this class of model is such a powerful tool in classifying and running queries on legal documents. A universal classifier, or a zero-shot classifier, is a machine learning model that is capable of predicting the class of an input, which it has never seen before in the course of its training. To do this, universal classifiers need to develop a generalized understanding of the structure of the kinds of input data it is expected to see. In the case of classifying text, or more specifically a legal document, a universal classifier must encode relevant information as to the repeated features of legal documents. Things like the meaning of common clauses, legal terms, past legal norms and rulings, and even the unevenness of contracts. Due to their specialized nature, zero-shot classifiers can outperform alternative large language inference models in terms of accuracy and efficiency, whilst also being more lightweight and portable. At present, Kanon is the most accurate zero-shot classifier for the task of legal classification, while our lighter-weight model, Kanon Mini, outclasses alternatives for its size and inference time. Before we can begin accessing the Kanon API, we must firstly make an account with Isaacus. Navigate to the sign-up page on our website, and be sure to read our terms of service before creating an account. After verifying your email, you should be redirected to our account portal. This is where you'll be able to manage your API keys, view your API usage, and update your account and billing information. You may also visit our documentation from this page, which is also accessible through our public website. To get started with running the model, we will need to generate an API key. API keys are unique codes that identify the usage of a user through a given user interface. To generate an API key with Isaacus, you will need to first add a valid payment method. This is to ensure that you are a unique user, and that we can bill fees based on the usage performed by your account. When inputting your payment details, you may see that there is a monthly per unit fee based on usage. What this means is that you'll be charged monthly depending on your usage of our models. At present, Isaacus offers two models, Kanon and Kanon Mini. Kanon is our flagship model, and is currently the world's most accurate universal legal classifier. Kanon Mini is a lighter weight version of Kanon, and boasts a cheaper price. Our API usage fee is scaled according to how many input tokens are processed by the model. For more details on how costs are calculated, please visit our cost page in our documentation. You should develop a decent grasp of the general pricing of our models by following this tutorial. Now that we understand the pricing model and have inputted a valid payment method, we can begin using the API. To do this, we must generate an API key, ensuring to keep this key private and secure. Click Create API Key, and be sure to copy it to a secure location. To get started, let's open a new Python file. The API is also available in JavaScript, and we are working on support for other languages as well. For this demonstration, however, I'll be using Jupyter Notebook to program in Python. We can install the Isaacus package with pip install Isaacus. We can then import the Isaacus API client from this library. The API client requires a valid key to be initialized, so we'll need to pass our API key as an environment variable, which is done by using the following code. For this demonstration, I'll be using Apple's App Store Terms of Service as the sample document that we will run queries on. This is accessible online as a markdown file via the following link, which will be included in the description. If you'd like to follow along on another file, feel free to do so by initializing a variable that contains your document as a string. Now let's print the variable to ensure that we have the right text. So now that we have initialized the API client and have our text stored as a variable, All that is remaining is a selection of our model and query. To do so, we use the following command, inputting our model choice, query, and text as parameters. For this tutorial, I will be using the flagship Kanon model, which is referenced as the Kanon Universal Classifier. So the first query I am interested in testing is whether or not Apple's terms of service grant the company the right to use my data. To query this, I can simply type the prompt, grants the right to use my data, in plain English in the query field. We then run this portion of code. By doing so, our client sends out the query and text input into the model of our choice, and then returns the output in the form of a classification object that we have saved to a variable. So there are three key values or objects that are packed into our stored output. The first is the document score attribute, which represents the probability that a query is true as generalized by the document. The second attribute of interest is our usage, which is accessible via the .usage attribute. For this one query, we have used 12,000 tokens, or the equivalent of only 1.2 cents at current prices. The final and most important attribute of our output is the list of chunks processed by the API. Chunks are simply a basic data structure representing portions of the document with references to its start and endpoints, and most importantly, the chunk score. As legal documents can be large and difficult to pass through, Isaacus provides a separate score based on your query for each chunk of the document. In other words, via the chunk attribute, we can see where exactly in the document the query is being satisfied. For the sake of brevity, I will be copying a portion of the code from the documentation, which will be available as a link in the description below. All this code does is print out chunks of the document that yield a score above 0.5. In other words, this code simply prints out sections of the document where it is more likely than not that our query is true, and ignores other sections of the document where our query is not satisfied. Note that it does not cost us anything to access or iterate upon these variables once our API call is made. All that is charged for is the initial call to the inference server to process our text and query. With all that preamble aside, it is time to finally see what Kanon is capable of. With a query of grants the right to use my data, we get the following result. Indeed, our query has been correctly fulfilled, as we can clearly see the portion of the Apple terms of service wherein we grant Apple the right to use our data, in one capacity or another. Notice, however, that nowhere in the extract do the words right or grant appear, despite using it in our query. Moreover, phrases referencing data appear about a dozen times all over the document, and yet, Kanon is able to infer that it is only this extract that relates to the granting of rights to use our data. This suggests that Kanon is more than just a blind search algorithm. The model understands contextual cues about how legal documents are structured, and can save you time scouring through a document that may reference a term multiple times, but not with the essential meaning you are interested in discovering clauses for. That isn't the only trick Kanon has up its sleeve though. Whereas Kanon is capable of processing queries worded in plain English, its full power can be realized through the Isaacus query language, or IQL. IQL allows users to make queries with logical operators that are optimized to be more accurate than plain language. For a full explanation of how IQL works, please reference the query page of our documentation. Nevertheless, I'd like to share with you two demonstrations of the power of the Isaacus query language. To use IQL, we need to encapsulate our queries in curly brackets and reference specific terms as standardized in our documentation. As an example, we can run the following prompt, which looks for a force majeure limited liability clause. Indeed, the Kanon model effortlessly finds this exact clause with a confidence level of 89%. As a final demonstration, let's get a bit more experimental. Big tech terms of services are known to be notoriously unbalanced and anti-consumer. But just how unfair these terms are can be somewhat of a mystery. With Kanon, however, We can design a query that is expected to capture some aspects of the potential unbalancedness of a contract, namely, whether or not what we are agreeing to unilaterally obligates us to do something, and whether or not the company is being unilaterally entitled to some right. To perform this query, we can use logical operators in IQL to get all the clauses that are unilateral and either obligate us to do something or entitle the company some right. Sure enough, the output we get reasonably matches our description of unbalancedness. For instance, we retrieve a clause protecting Apple from copyright infringement, a clause permitting Apple the right to use our data, a clause granting Apple the right to arbitrarily remove content that we have purchased if it becomes unavailable on their services, a clause granting Apple the right to disclose your data to law enforcement or third parties, a clause reserving Apple the right to modify, suspend, or discontinue their services at any time for technical or operational reasons, a clause compelling us to follow certain content policies, and finally a clause that allows Apple to update your payment details against your will to charge you outstanding fees as permitted by local law. All of these clauses match our description pretty well, so I think that's pretty cool if you ask me. Finally, we can review our API usage page by returning to the Isaacus portal. So through the course of this tutorial, we have used approximately 65,000 input tokens, or the equivalent of only 7 cents. And this is whilst using our flagship Kanon Universal Classifier model. For more information on our products and services, be sure to visit our website and follow our socials. Until next time, this is goodbye.